Reliability, the ability of a system or component to perform its required functions under stated conditions for a specified period of time. Culture, the set of shared attitudes, values, goals, and practices that characterizes an institution, organization, or group. The reliability culture is a continuous process for looking after the different systems' performance and improve them, driven by the shared attitude and common practice in our organization. Responsibility. It is not everybody's responsibility to build and have a reliability culture in the organization, but it is a hierarchy responsibility shared with all employees as per their respective fields. The components of reliability culture can be described in 3 words. Focus, on what drives the results instead of the results. Proactiveness is an improvement, foresight, and/or execution of activities that will prevent equipment, process, or human failure or minimize the consequence of failure. Priority is putting things in the right order. To enhance the reliability culture, we have to move from present sight to foresight, from recognize reaction to recognize proactiveness, from restricted information to open flow information, from to do everything that comes up to do what is most important, from spot learning to continual learning, from big-ticket improvements to continuous improvement, from identifying potential failures to reducing potential failures, from focus on major failures to focus on chronic failures. IBNSINA has 4 reliability methodologies: RBI, RCM, RIS, RCA. RBI, Risk-Based Inspection. It is one of the reliability methodologies that is adapted in IBNSINA to enhance the mechanical integrity of the plant stationary assets, like pressure vessels, heat exchangers, storage tanks, etc. We have heard many times about risk, and now we will understand what risk is. Risk is a product of probability of failure and consequences of failure, which applies in all situations. In other words, risk is something we live with every day and is involved in all simple and complex decisions. Risk cannot be eliminated, but can be controlled by controlling the probability of failures, since the consequences are beyond our control. And that is why RBI methodology is used in controlling these risks for plant assets. RBI methodology is a risk assessment and management process which is focused on loss of containment due to material degradation, where the risks are managed primarily through inspections. It generates inspection strategies based on risks involved, unlike conventional time-based inspection. Good results are achieved by the effectiveness of the team, which is prominently from inspection, operation, maintenance, and engineering. The benefits that are achieved by utilizing RBI are risk ranking, to know the severity of the risk, identification of potential failures, developed detailed inspection strategy, inspection optimization, cost-effective inspection, risk mitigation activity, enhance plant asset integrity. RBI methodology complies with API international standards like API 580, API 581, API 510, API 570, API 653. RCM, Reliability-Centered Maintenance, is an analysis that tells us what all should be done so that our assets perform in the way we want them to. Basically, the asset system is studied to determine 1. What can fail, 2. How it can fail, and 3. How the failure affects us in terms of environment, health, safety, revenues, and costs. Once we know this, it is easy to evolve our operation and maintenance strategies that will mitigate the risks to acceptable level. RCM is a teamwork of best staff from operations, process, and maintenance. This team applies FMEA methodology to a plant system. As a result, it becomes evident what we are missing in our maintenance plans, condition monitoring schedules, and operating procedures. Or, are we overdoing something? Having known this, we focus on the really necessary things rather than spending our efforts in anything and everything. It's like drip irrigation against conventional flood irrigation. Then the fruits are sure to be good. RCM results in safe and reliable performance of assets at an optimum cost. The understanding of the systems improves due to multidimensional view of the cross-functional team members. Finally, reliable performance and reduced downtimes will yield increased profits, increased safety, and better environment. This is RCM, Reliability-Centered Maintenance. RIS, Reliability Instrumented System. In a process plant, day-to-day demands are safety, quality, cost saving, risk management, and process availability. As a professional, how do we manage those demands? The solution is to tackle the demand by a systematic approach. As a lesson learned from our earlier experience, International Standard IEC 61511 was published in 2003 to provide guidance to safety instrumented systems in the process industries. This standard is based on IEC 61508 for design, construction, and operation systems. In process industries, to achieve safety, quality and plant availability shall be achieved by a concept called Asset Performance Management, or APM, a set of work processes to maximize physical asset performance, mitigate risk, and optimize cost. RIS, Reliability Instrumentation System, is one of the modules under APM dedicated for instrumentation systems. What does RIS stand for? RIS is a methodology for performance management of process instrumentation as well as safety instrumented systems. The workflow for RIS starts from a PHA study, risk analysis, SIL calculation, layer of protection, LOPA, LOPA recommendations. The expected benefits from APM and RIS are assessment and documentation of safety instrumented systems, testing standards for safety instrumented systems, standardized measurement of equipment failures, standardized calibration methods, managing recommendations for improvements and change, monitoring and sharing best practices. Root cause analysis. RCA is a methodology for investigating why failure happens and to identify and eliminate the root causes of the failures so that reoccurrence of the problem is prevented, mitigated. Our aim is to promote IBNSINA employees' knowledge and skills about root cause analysis methodology to drive a problem-solving culture change that will positively impact SABIC reliability performance. Investigation path. The investigation process consists of 4 main steps that should be carried out in order to ensure investigation is proper and its outcomes are satisfactory. Those steps are: 1. What happened? Identify and describe the problem, known as problem statement. 2. How it happened. Gathering data. Putting events prior to the incident in the right order, known as timeline. 3. Why it happened. Analyze the incident to identify root contributing causes. 4. What to do. Developing recommendations. Sharing key learning. Root cause. The root cause is the cause that, when removed, changed, or controlled, the problem does not reoccur. In addition, it is the most basic cause or causes that can reasonably be identified, which management has control over and can fix. Investigation quality elements. In each incident investigation, there are 3 elements that should be granted to achieve the expected results of the investigation: team knowledge and skills about incident nature and investigation methodology, available data about the incident, allotted investigation time. RCA benefits: saves lives, better complying with EHS regulation, prevents and predicts similar occurrences, increase reliability, business performance, profitability. Give people the abilities to handle problems with knowledge, skills, and confidence. Enhance reputation.